Hello guys, hello friends. I welcome to you all to my this new channel. In this channel, I will instruct and teach you Azure DevOps from scratch. So if you are a beginner or a working professional, so this course is only made for you. Don't be scared if you are a beginner and just new to cloud and DevOps technologies. This course will help you to give a 360 view of Azure DevOps and Azure fundamentals. So just stick with me. So a small introduction about myself. My name is Aman Kumar. I have 3 years of working experience in cloud and DevOps technologies. I am AZ400, AZ104, AZ204 certified Azure Cloud Developer. In this course, I will mainly focus and teach you AZ400. So the first question arises, what is DevOps? So DevOps is a combination of software development and operations. It is defined as a software engineering methodology which aims to integrate the work of development teams and operations teams by facilitating a culture of collaboration and shared responsibility. So, as you can see in the image, there are two phases, development and operations. We are trying to integrate the work of development teams and integration teams, operations teams, by facilitating a culture of collaboration and shared responsibility. As you can see in development itself, there are many phases like build, code, plan, test, and every phases consist of multiple phases like automation in build and development, and in code cycle we can see source code version control. Similarly in operations there are many phases of deploy, operate, monitor. So we will see one by one all this aspect when we will cover each and every topic of DevOps. So moving ahead, what is Azure DevOps? So Azure DevOps is a set of development tools and services provided by Microsoft as a part of Microsoft Azure cloud computing platform. It provides a comprehensive set of tools for software development, continuous integration, continuous delivery, CI/CD as mentioned, and project management. In Azure DevOps, it is designed to support the entire software development lifecycle from planning and coding to building, testing, and deploying applications. So Azure DevOps is offered by Microsoft as a cloud computing platform which provides our development tools to integrate our DevOps methodologies into our applications. So we will move ahead and see what is AZ400 certification. The name of the exam is Designing and Implementing Microsoft DevOps Solution. This exam will measure your ability to accomplish the following technical tasks like configuring process and communication, designing and implementing source control system, designing and implementing build and release pipelines, developing a security and compliance plan, and implementing an instrumentation strategy. So the price of the test in India is 14,800 Indian rupees, and I have shared the link below. You can go then and check it out and schedule the exam right now. So till in this video we will cover only this. Later we will see on next video. So today we are going to cover some topics. So we will move ahead and see. But before that, please like and subscribe my channel. I hope you will enjoy this content. So yesterday we have seen the basic overview of DevOps, like what is the definition of DevOps and what is Azure DevOps, and about certification also. So now we will move ahead and see some more topics. So so we will see a glimpse that what we are going to cover in throughout this course. So first of all we can see we have Azure boards. Azure boards, short definition, it helps us to plan, track and discuss work across teams, deliver value to your users faster. Like it's like a board, a dashboard in which we can write everything our project related, and we can track those changes by writing uh, and taking a track of that thing. Then we can see we have Azure Repos. Azure Repos, it is a type of Git repository. If you have worked before to any of the repositories like GitHub or Bitbucket. So you have already are familiar or not, then don't worry, we will cover Azure Repos in depth and see what is and how it works. So it is like unlimited cloud hosted private Git repos, collaborative, pull request, advanced file management, and more. So next is Azure Pipelines, the heart of our DevOps. So it is a CI/CD, that means continuous integration and continuous delivery, that works with any language, platform, and cloud. Connect to GitHub or any Git provider and deploy continuously to any cloud. Like Azure Pipelines will help us to deliver our continuous integration and delivery pipeline, and it can connect to any language and any platform of cloud. Then there is Azure Test Plan. It is a test management and exploratory testing toolkit that lets you ship with confidence. It is for testing purpose, but as we are not testers, so we will not go in depth of that. We will skip the Azure Test Plans. We will stick to one definition. Then the last is Azure Artifacts. It is used to create and host and share packages. We can easily add artifacts to CI/CD pipelines. Artifacts means the configuration and dependencies which we will use in our code, or it can be the build files which are generated in our code. So we are going to store those things into Azure Artifacts. So now move ahead and we will see. So there are some basic concepts in DevOps. We should first understand those things. First is organization in Azure DevOps. So before moving to Azure boards, repos, and other toolkits of DevOps, first we should understand the basic organizational structure of DevOps. That's how the hierarchy works in DevOps. In Azure DevOps mainly, but first we will see what is organization in Azure DevOps. So in Azure DevOps, an organization is a top level container that represents a collection of projects and resources within the Azure DevOps ecosystem. Organizations provide a way to manage and organize your software development and project management activities. That means organization is a top level container like thing that represents a collection of projects and resources within ADO. That means Azure DevOps. That means the projects and the resources we are going to create in the organization itself. If you are not getting this thing, then we will see it practically and you will be more clear about this. So just stick to the definition as of now. It is a top level container that represents a collection of projects and resources within Azure DevOps. Then there is one more concept, projects. So within an organization you can create one or more or multiple projects. Projects are used to group related work such as software development, and they include features like repos, boards, pipelines, and more. So all the tools that we have covered previously, we are going to use them in the projects itself. So first we are going to create an organization in Azure DevOps, and within that we are going to create projects, and then we will start our projects. So let's move ahead. First we will see creation of organization and projects. So now we can just Google into our browser Azure DevOps. We can click on the first link. We can click on start free. But the first time if you click on start free, then you will get a, a page where you have to create an account with Azure DevOps. So you should create an account. You have to just provide some basic details like your email ID and your name and those things, and then you will can create your Azure DevOps account. I have already created that, so we will skip that, but if you want, then you can comment, I can do that for you also. So I have already created our DevOps account. So let me just create a new organization. So if you first of all when you are signing into DevOps, you will get a page like this. Here you can see there is saying getting started with Azure DevOps. So I will just continue. So you can see we have to provide our organization name. You can see name of organization. So I will just train lab training 01. So this is a location where Azure will host your projects. As of South India is okay for me. Validation, and So I will click continue. It will take a while to set up your organization. So guys, here in left side you can see we have multiple organizations here, and this one I have created just now, lab training 01. So here it is in the organization itself, it is saying to create a project. So we have to create a multiple projects we can create. So I will just create first project, my first project. We can create public or private. So we will just create a project. So guys, I hope you understood. So we have first created our Azure DevOps organization, and within that we have created our first project. So you can see the hierarchy, the first organization name, and then the first project. And here you can see all the toolkits that we have covered previously: boards, repos, pipelines, test plans, and artifacts. Okay, so as of now we will cover this much only. In next video we will see how the tools works in Azure DevOps. So we will cover next topic today, but before that please like and subscribe my channel. So today we will see Azure Repos and how Azure Repos work in Azure DevOps. So Azure Repos is a version control system and source code repository service provided by Microsoft as a part of Azure DevOps Services, formerly known as Visual Studio Team Services Suite. It is used for managing and tracking changes to source code and other development assets. Azure Repos offers two main types of version control systems. First one is Git. Azure Repos supports Git, which is a distributed version control system. Git allows developers to work collaboratively on code by providing features like branching, merging, and distributed repositories. You can create Git repositories in Azure Repos and use Git commands and workflows to manage your source code. Second one is Team Foundation Version Control, also known as TFVC. Azure Repos also supports Team Foundation Version Control. It is a centralized version control system. TFVC is suitable for teams that are more familiar with centralized version control models, though it lacks some of the distributed features of Git. So nowadays we use distributed version control system instead of centralized version control system, because distributed version control system has many advantages as compared to centralized version control system. We will see in next slide. So we can see the architecture of distributed version control system, how it works. So first one is the repository. So on the top level there is a repository, and that is a server repository. That means the repository is hosted on a server like Azure Repos or Git or any GitHub or any third party service provider. Then the second layer consists of multiple repository. As you can see, there are three repositories which are local copy of repositories. We can see in last there is working copy of workstation 1, and second workstation and third workstation also have working copy, and they have a repository. So by this diagram we can see that PC1 has its own working copy and it is committing or updating code into local repository of second layer. Same with PC2 and PC3. So with the help of distributed version control system, we have two repositories. First repository is in our local system and the second one is on the server. So for our local repository, if we want to push our code to server repository, then we do a push operation, and push operation will upload or push our code from local to server. And if we want to fetch the code or download the code from server repository to local repository, then we do pull operation. So simultaneously we can see all the PC are doing the same thing. This is the main advantage of distributed version control system. Today we will see more topics in Git. So let's get started. But before that, I request you to please like and subscribe my channel. Thank you. So moving ahead, you will see some basic Git commands. So there are some basic Git commands that every developer or every IT software engineer should know. So these are the basic commands which helps you to push or pull your code from local to Azure Repos or any version control system or vice versa. So the first command is git clone. This command is used to create a copy of a remote repository on your local machine. It downloads the entire repository including all branches, commit history and files. So git clone is used to copy a remote repository to your local machine. Then there is git add. So this command stages changes for commit. It tells git that you want to include update to a specific file in a next commit. You can specify the file if you want to stage, or you can use a dot to stage all changes. So git add is used to stage the commits. Like I have explained you previously how git works. So git will push files from local directory to staging area with the command of git add. Then there is git commit. This command creates a commit which is a snapshot of your repo at a specific point of time. It captures changes that have been staged using git add. You should include a meaningful commit message to describe the changes made in the commit. Moving ahead, we will see two more commands. So these two commands are very useful. So first one is git push. This command is used to upload a local repo content to a remote repository. It is typically used to publish changes made on the local branch to a central repository on services like GitHub, GitLab, or Bitbucket. So git push is used to upload your local repository content to remote repository. Now the second one is git pull. This command is used to fetch changes from a remote repository and merge them into the current branch. It is equivalent to running git fetch followed by git merge. So we don't need to go into git fetch and git merge as of now. Just try to understand like this. Git pull command is used to copy your updated content of your remote repo to your local server. I hope you understood. Now we will see some practical and then we will get a clear understanding about this. So we will first see how we can clone an Azure repo. So you have to download Git for Windows before doing any Git related task. So you can install an 64-bit Windows setup if you are Windows 11 you are using, and you have to install. I have already installed Git, so I will be not doing that again. You have to just click on this and download this file and uh, leave all the settings at default and just install this. After installation, you will get a Git bash, like you can see. This is my Git bash. So we will be using this git bash to do our git operations. So guys, once again we are on our homepage of our Azure DevOps. So in previous video I have shown you how you can create Azure DevOps organization and projects. So I hope you have learned those things, and if not, just go to my previous video and see that. So moving ahead, now I will click on my first project and I will go into my first project. We have to click on Azure Repos. After clicking that, we can see that my first project is empty. Add some code. So as of now we don't have any repository, so we need to create one. I will just click here and click a new repository. I will type the name my first repo. I will add a readme file. I will click on create. As you can see, I have created my first repository, and my first repository only has a readme file as of now, and it is empty. You can see context only readme file. So we are going to push a demo code into here. We will just click on clone. We will get two type of cloning method. First is HTTPS and second is SSH. So we will not using SSH, we will use HTTPS. So guys, you will just click here and copy the HTTPS link. We'll go where we want to clone the repo, and here we will open the git bash. or you can use your terminal or command prompt also. We will type git clone and the URL we will paste, and after that you can see there will be a file generated here with the name same as my Azure repo. My first repo folder will be created here, like means that this repository on my server will be cloned here. Just click on enter. See, as you can see, my first repository is cloned. Now you can see it will consist same no files. As you can see, I have only readme file in my server and I have only readme file in my local repo also, because I have only readme file in my server repo, so it has cloned the readme file. So now we will try to add some files here and we will try to push those files from here to Azure DevOps Azure Repos. I will copy the code. This is the code I want to push to Azure Repos. I will go back to desktop, my first repo. I will paste the contents. I will skip the readme file. After that, I will open my git bash, and before that, we can see we are in desktop right now. We don't have the access to our code, so we can't push the code. So we need to go inside this folder. Like in first repo, we need to go here. So we will do cd command and my first repo. Now we are in our correct path. We can see we are in desktop, my first repo. So we can see the files also by doing ls. We can see we have all the files in my local repo are present here. Now we will try to push this file to here. So I hope you guys remember the commands I taught you earlier. So first we will do git add and a dot to selecting all. This command will move all my files to local repository. Okay, now we will do git commit -m and give a message first commit. So git commit will create a snapshot of all my files to staging area. It has done, and now git push will push the code from local to server. Okay, we can see it has been done. Now if I refresh my server repo, and you can see all the files which I have in my local has been pushed to server. So that's it guys for this video. Now we will see some more topics in git, or I should say Azure Repos. So we will see branching strategy and then merge conflict and pull request also. So moving ahead, please like and subscribe my channel. Moving ahead, first we will see branching in Azure Repos. So branching in Azure Repos refers to practice of creating separate lines of development within a version control repository hosted in Microsoft Azure DevOps. Azure Repos provides a robust version control system that supports both Git and Team Foundation version control, and branching is a fundamental feature of these systems. If you are using Git in Azure Repos, branching is a lightweight that and allows you to create independent branches for different features, bug fixes, or experiments. Each branch is a copy of the main codebase, usually called the master or main branch, and can be used to work on a specific task without affecting the main codebase. So now we will see how branching works. So guys, I am in my Azure DevOps homepage once again. I will go to my first project. Now we will go to Azure Reports once again, and we can see I have this my first repo, and in that we have this main. This is our main branch. Okay, we can now create many branches as we want. I will click a development branch. So it is based on main branch. So what does it means? So we are creating a branch, that means a same copy of our main directory named as development directory. But if we do any changes in development directory, the changes will not be reflected immediately in main directory or main branch. I'm saying directory because it will help you to understand more clearly, but you can say branch also. So this development branch has the same code as main branch, just the development branch is a copy of main branch with a different name. But if I will do any changes in development branch, like if I create a new file like a sample.txt file, so, and let me just add something, hello, commit. So you can see in my development branch I have created a sample.txt file, but in my main branch it will not reflect because I haven't done pull request to merge the development branch to main branch. So we will see merge how we can merge these two branches using pull request in later videos or later topics, but as of now just stick to the definition that we can create as many branches for as many purpose, like development for developing application. Like if you want to add any feature, so we can create in that development branch. And if our main branch in its production, like the main branch is functioning like a web app is deployed using main branch, then the main branch will not be affected until we merge these two branches, both branches. So we can do any task in development branch and it will not affect the main branch. We can create one more branch like patch, and we can make it based on developed branch or main branch. So if we will create based on development branch, then the new branch patch will also contain the sample.txt file because it is based on the development branch. And if we create patch 2.0, and if it is based on main branch, then it will not contain the sample.txt file because it is based on the main branch. So I hope guys you understood how the branching works. So moving ahead, now we will see the next topic. So moving ahead, now we will see pull request and branch policies. So let's get started. So again, so hello guys, so we are in my Azure Repos, and we can go to branches and we can do the same thing like creating new branches or deleting any branches. We can see history also, we can see few files also, we can log the branches also. Okay, now we will move ahead and see some branch policies. Like the patch is a uh, very important branch for you, and you are working on something in your patch branch. You can go to branch policies, and we can see there are many policies that you can apply to your branch. Like you can add code reviewer also, so that if you do a pull request, then the code reviewer can review your code and authorize your changes. The code reviewer can be your manager or your senior team member. So I will just add one code reviewer. You can add your code reviewer here and they can view your code before merging the branches. So just now we will see the pull request. So pull request, as I told you earlier, like I have a file patch 2.0 branch. I have a branch patch which contains a file sample.txt. I hope you can see. And I have main branch which does not contain this file. So I want to merge patch to main. So this merging is called pull request. So we will go to pull request, create a new pull request. The source branch will be patch and we will merge it into main. As I already told you, just give me 1 second. I will again that I have one file in my patch. I have developed some feature and I want to integrate in it main. So I will just create a pull request and I will integrate patch into main. So this is the title and description we can add. We can add reviewer like your manager or anyone who can review your work before creating this pull request. As of now, I will not add anyone. Just click on create. It is saying no merge conflicts. Okay, just complete. and we can see the pull request is being done. Okay, it is now completed. We can go and check it out. So we can see in our main branch we have sample.txt file. So this is called pull request. I hope you guys understood. Moving ahead to next topic. Now we will see merge conflict. So what is merge conflict? A merge conflict in Git occurs when there are conflicting changes in the same part of file in two different branches that are being merged. This typically happens when you attempt to merge changes from one branch to another, and Git cannot automatically reconcile the differences between the two set of changes. So now we will see practically what does that means. So guys, now we will see merge conflict in Azure Repos. So we will use our first repository for this also. We have created sample txt earlier. You can see there is one code here written hello. Now in second line, I will add some code like hello server repo, and I will commit the changes. So after committing changes to server repo, it will not immediately reflect the changes to my local repo, because as I told you earlier, we have to do pull request to synchronize the local and server repo. So the changes will not be reflected to my local repo. Let's see. So guys, for this task we will use VS Code, because it will give a good overview how merge conflict works. I will just open the folder where earlier I have stored my code. So these are the files. See, sample.txt is here, but it is not synced or pulled, so it is giving me the older version of the sample.txt. If I add something here on the same line, line number 2, like hello local repo, and if I try to push these changes to my server repo, commit, and if we sync this, sync means push or pull. So if we sync the changes, we can see we will get error. See, it is saying, it is giving error, and we can see it is saying the current change is local repo that we are doing locally, and the incoming change is server repo that is incoming from server. So how we are going to solve this? We can click on resolve in merge editor, and we can see. So we can see incoming change server repo in line number 2, and current change is local repo. And here is the output that we will give in the last. So there are multiple options to solve this: except incoming, except combination. Same here, except incoming, except combination. So I will accept the local repo, accept current. So the output will be like this: hello local repo, complete merge. Now I will do the last operation, and you can see our final changes has been pushed here that we have solved. So that was merge conflict, friends. I hope you understood. Now we will see next topics in later. So previously we have covered Azure Repos in depth. We have seen all the definition and hands-on lab on Azure Repos. Now we will move ahead and we will see some other topics. Before moving ahead, I would request you to like and subscribe my channel so that you can support me for creating new contents. So first we will see our agenda of today. We will see what is CI/CD, then we will see Azure Pipelines overview, then hands-on Azure Pipelines. At last we will see pipeline YAML file and hello world pipeline. Moving ahead. So first we will see what is CI/CD. So CI/CD stands for continuous integration and continuous deployment or continuous delivery. It is a set of software development practices and tools that aim to automate and streamline the process of building, testing, and deploying software applications. CI/CD is a crucial part of modern software development and is used to ensure that code changes can be quickly and reliably delivered to production environments. Now we will see Azure Pipelines. Azure Pipelines automatically builds and tests code projects to make them available to others. It works with just about any language or project type. Azure Pipelines combines continuous integration, CI, and continuous delivery (CD) to test and build your code and ship it to any target. Now we will see hands-on Azure Pipelines. So guys, I am in my Azure DevOps in Lab Training 01 and Project 1. If you don't know how we are creating this project, so please refer my previous video. You will get all things. So previously we have created one repository. Now we will create another repository. So I have created a new repository, my first repo, and in this repository I don't have any files right of now. It is an empty repository. So our main focus on this video will be on Azure pipelines. So we can create Azure pipelines by two methods. Either we can create on click on setup build repositories, or we can go to pipelines, and in this section we can create on create pipeline. Now first it is asking that where is your code. So you can choose any version control system. In our case we are having our repo in Azure Repos Git. We will click on this. We will select our repository. Now it is saying configure your pipeline, and it is giving us two options: starter pipeline or existing Azure pipeline. So as of now we don't have any existing pipeline YAML file in our repo, so we will use starter pipeline. So this is our YAML file. So guys, if you are not familiar with YAML files, so YAML files are those files which are a written code which helps us to run your pipeline, or you build your pipeline and do every job that you want to do in your pipeline. So YAML file helps in that. So YAML file is very easy language. It is very easy and human readable language. You can easily understand. So first it is saying trigger. So what does trigger means? Okay. So trigger represent that thing where our code is in the branch. Like, let me show you. Like in Azure Repos, we are fetching our code of main branch. So it is just saying trigger the main branch. So it is highlighting our branch. You can see here it is written also branch name. Then pool. So what is pool? Pool is like a agent or a virtual machine in which our code will build. You can see pool is where the job will run. It is saying also. So which virtual machine image we are using? We are using Ubuntu latest. You can use Windows also. Let me try Windows. So this virtual machine is working behind the scene on Azure backbone. We can't access directly, but we can access it with help of this pipeline. We will see it later how we can access this virtual machine and get all the information about our build code. So as of now we are using Microsoft hosted agents or virtual machines. We are not using our own hosted agent, but we can use our own self-hosted agents also. We will see in later videos. So we can see there is a step is described. So the definition is a list of steps to run this job. So first job we are doing is we are calling a script, a bash script, and in script we are writing echo hello world. That means this hello world would be print in our terminal. And display name, the name of this job itself is run a one script. Okay. So then there is second script we are also running, add another task to build, test and deploy your project. Echo see this and display name run a multi-line script. Okay. So we are doing two job, performing two tasks. First is to print hello world, and second is to print this, and the name of this job is run a one line script. run a multi-line script. You will get more clarity when I will run this pipeline. Just we have to click on run. We can give a commit message and just save and run. So it is saying it is creating pipeline. We should wait a while and see. So it is giving us all the metadata. This is the commit ID and the commit message. This is our repository name. So summary is that this is pipeline is triggered or run by Aman Kumar. Time it is taking 17 seconds and further it is taking. Now we can see our job is completed. It is showing a green tick and the status is success. So we can click on this and see the result. So we can see the jobs. If we click on first job, so it is showing pool is Azure pipelines, images Windows latest, and agent is hosted agent. So it is just saying that Microsoft Azure is using its own agent to build our job. Second, initialize job. It is just acquiring some metadata. We don't have to go into this depth. So first job, it is doing the checking out my repository into its local machine, like the thing we have done previously, that we are cloning our remote repo to local machine. That thing it is doing by automation. It is checking out our remote repo or server repo to its local machine build agent. We can see also git version, it is checking the git version, then git remote add origin, then everything it is doing behind the scene. So after cloning our repo, first job it is running, the job I mentioned you earlier. Just let me show you the YAML file once again. Click on edit and YAML file will be opened. So the first job that I have shown you, the display name, the job name was run a one line script. So you can see the job name is run a one line script, same thing, and it is just running the job. What was the job? Job was to print the hello world. So you can see script contains, it is a type of shell script and it is printing hello world. Now we can move ahead to second job. We can see run a multi-line script. See, run a multi-line script, and the job was to print this thing. So this thing it should print. See, same thing. So guys, it was a simple hello world pipeline. Now we will see for. I hope you understood my previous contents and you have enjoyed those things. So we will move ahead and see some more topics in Azure pipelines, and we will briefly understand those things. So please like and subscribe my channel for supporting me. First we will see today's agenda. We will see YAML file in brief, then environment variables in Azure pipelines. Then we will build a sample React code on local machine. YAML file. So I have discussed previously YAML file in brief, but for your more understanding, I will discuss once again. So you can see this image. This is the image of a YAML file, of a simple YAML file, which is installing Node.js and running some task for a Node.js application. A Node.js application can be any React or Node.js or Next.js application. So you can Google it out, what is Node.js and what are React and Next.js applications. So the first line itself, you can see it is saying trigger, and trigger is develop. So this section trigger defines when the pipeline should be triggered. In this example, the pipeline is triggered when the changes are pushed to develop branch and when pull requests are created. So trigger specifies the branch in which we are doing changes. And the second line, you can see there is pool. So pool specifies a pool of virtual machines to be used as build agents. In this case, it is set to use as Ubuntu latest VM image. Then in third you can see that is steps. This section defines the sequence of steps to be executed at part of the pipeline. In the first step, you can see there is a script that prints viewing files before building the code. So it will just print out the script, and in second line of script you can see there is ls, that means listing the directory of build.source directory. So don't get confused. $build.source directory is an environment variables in Azure pipeline, and we will see it in depth. Then there is a task. You can see the task is node tool @0, and the input parameter is version spec 16x and display name is install Node.js. So this task is installing Node.js in our build machine, and the version of node it is installing is 16. The display name is installing the Node.js. Then in the last script we can see it is running some commands, npm install and npm run build. So these two commands are used to install the dependencies and run the build file, that means to compile the code. So I hope you understand the structure of YAML file. So this is the way a YAML template should look like in Azure pipelines, and you should give commands like this. And in steps you have to describe what steps you are going to perform to build your pipeline. So I hope you understood. Now we will see the environment variables. So environment variables. Variables give you a convenient way to get key bits of data into various parts of your pipeline. This is the list of predefined variables that are available for your use. So some environment variables, you can see the first one is build.source directory. It is the directory on build machine which will be used for check out your source code from Azure Repos and then compile it and build. Now the second one is build.artifact staging directory, the local agent path where any artifacts are copied to before being pushed to the destination. So these are some examples of environment variables. So environment variables are predefined variables in Azure pipelines which gives us many uses in our pipeline so that we can access our build agent via this environment variables or do any other tasks. So you can see more variables. I have provided the link. You can go and check it out. So guys, you can see there are many predefined variables and you can use this variable to do your task. So you can see it has given a brief discussion of the variables and how you can use those in your pipeline. There are many variables. You can see agent machine name, agent OS. It will give the operating system of your agent. There are build variables, artifacts in directory. See, everything is written here. You can go and check it out. So mainly we will using this variable and second one build.source directory. Let me just see where is that. Yeah, this one. So just let me explain it thoroughly once again. So build.sources directory, the local path on the agent where the source code files are downloaded. So this is the path in your build machine. So I have told you previously that we can't access your build agent directly because it is working behind the scenes of Azure pipeline. So by using, if you want to see which files are created, which files are deleted with the help of YAML file, so you can use this variable to see those things. And the same goes for this one build.artifact staging directory. So it is a local path on agent where any artifacts are copied before being pushed to a destination. For example, this is the location of your machine. So you can copy your build files to a separate directory, that is build artifact staging directory, and you can do tasks from there. So you can check it out. The link I have provided. So now we will see the commands to build a node applications or node based application. So first one is npm install. It will install or download the packages or dependencies to build your project or code. Second one is npm run build. It will compile build your code and generate artifacts, that is build files, which are going to be deployed. And the last one is npm start. It will start your application inside a browser. So these three commands are used to build any node based applications. You have to use in this sequence only: npm install, then npm run build, and then last npm start. But in case if we are going to deploy this node application into Azure pipelines, then npm start will not work. We have to do npm install and npm run build, and then after npm run build, all the build files will be stored in an artifact folder, and from there we will take the build files or artifacts and we will push it into a Azure web app. So I hope you guys are understood as of now. We'll see how we are going to build a React app locally. So before building React application, you have to download Node.js software or tool in your local system. So you can Google Node.js download and you will get the application here. You can download the Windows installer if you are using Windows, and other operating system you can also do those things. So you have to install it in your local machine to build your files locally. I have already installed, just let me show you. This is the application you have to install to compile your code. So guys, I have already created a sample application of React. I will provide the GitHub link of this. You can go and download the code from there and you can build your code. So this is the file. This is the code of the React app we are going to build. So we will first open command prompt. After that, you can see I am in my users. Now I have to go into this path. So I will just copy this path and I will just change directory. Now I am in my first repo, as you can see. Just cross check by viewing the files dir. You can see all the files are here, are listed here also. So I am in my correct path. So you have to learn some commands or know some command before building your node application or React application. So guys, don't get confused of Node.js or React.js. So the Node.js is application or a tool for building multiple JavaScript based applications. So one flavor of that is React applications. So React application is based on Node.js only. So we are going to give the first command npm install. So npm install will install all the dependencies and libraries from the central repo of Node.js to our local repository. You can see after giving the command, I have now one folder created or generated node modules, and node modules will have all the dependencies to build this project. You can see it is downloading all the files. It will take a while. So guys, you can see everything is completed. Now you can see node modules has been installed successfully in our folder. You can go and see there are many packages or dependencies that are used to build this file. So second command, we have to get npm run build. So this command will generate the build files. That means it will compile the code and generate the build files which are going to be published later. Click enter. It will also take a while. You can see it is saying creating an optimized production build, and you can see a build folder is generated right now. So if you will compare, previously we don't have these two folders. These two folders has now been generated, build and node modules. Node modules have all the dependencies and packages which is used to build this project, and build folder has all the static files which is going to deploy on a web page. So this build folder is also known as artifact folder. So here you can see we have these files. So these files is called artifacts, and we are going to store these artifacts into a separate folder and release these artifacts later point of time. We will see in Azure Pipelines in more details. So guys, you can see our job is been successful and our build files has been generated. See, so this you can see these are our build files, and these are also called as artifacts. So it will be stored inside our Azure pipelines as artifacts, a separate folder, and later point of time we are going to deploy these things only. So now we will just run one last command, npm start, and it will start our application in a browser. You can see a web page, and you can see it is saying you can now view hello world in a browser. This is the IP address or localhost 3000. See, our application is up and running. So this is how we are going to build and run our React app or any node based application in our local system. So in previous video we have seen how we have deployed a next Node.js application in our local system. Now we will see some further topics like how we can deploy the same Node.js application or React application in our DevOps pipeline. So before that, I request you all to like and subscribe my channel. So let's get started. First we will see today's agenda. We will see setup of deploying an application on Azure pipelines. Then we will see what is CI/CD. Then we will see setup of build pipeline. So moving ahead, first setup of deploying an application on Azure pipelines. So guys, this is the strategy of how we can deploy a Node.js or React.js application to our Azure pipelines. So you can see this diagram states a clear picture. In first step you can see we have Azure Repos. The work of Azure Repos is that we are storing or pushing our code from our local system to Azure Repos, and then we are checking out the code from Azure Repos to step number 2, that is build pipeline. We are checking out our code from Azure Repos to build pipeline. Then we are creating a YAML file and compiling the code into build pipeline, and at last we get build artifacts. That is step number 3. We are generating build artifacts, and then in step number 4 we can see we are calling a release pipeline, and we are calling all the build artifacts from step number 3 into step number 4, the release pipeline. So the steps from 1 to step 4, we have compiled our code and successfully generated the build artifacts in Azure DevOps. Now we have to deploy our artifacts to a web app or web application. So we need some sort of service connection to deploy, or a communication between our Azure DevOps and the third-party server or application, so that we can push our artifacts from DevOps to another service or third-party provider. So we need a service connection. So service connection we will see in later, but as of now just think it as a type of communication between our Azure DevOps and a third party provider services like GitHub, Microsoft Azure, or any other services. So we are creating a service connection, a connection between our Azure DevOps to Microsoft Azure. So in step number 5 we are creating a service connection, and in step number 6 we are pushing our or releasing our artifacts from release pipeline to Azure web application. So if you guys don't know, so Azure web application is used to host our web page or our artifacts. So I hope this strategy is well understood for you. Moving ahead, now we will see what is continuous integration and continuous delivery. So continuous integration, it involves automatically integrating code changes from multiple contributors into a shared repository several times a day. The main goal is to detect and address integration issues early in the development process. Automated builds and tests are run whenever code changes are pushed to the repository, helping to ensure that the new code integrates well with the existing code base. Then second, is continuous delivery. It extends the concept of CI or continuous integration by automatically and consistently delivering software to production-like environment. In a continuous delivery pipeline, the application is automatically tested, and if all tests pass, it is automatically deployed to a stage of pre-production environment. This allows teams to have a reliable and repeatable process for releasing software at any time. Then we will see a diagram how continuous integration and continuous deployment work. So first we can see continuous integration. It involves of Azure Repos, build pipeline and build artifacts. We are calling or checking out our code from Azure Repos and triggering a build pipeline from that and generating the build artifacts. So this cycle is continuous. That means if any developer makes a new feature in our code base of Azure Repos, then build pipeline will automatically check out the code from Azure Repos and automatically generate the build artifacts. There is no manual intervention. So this is called continuous integration or CI. Then we can see continuous deployment or delivery. So we are taking our build artifacts to release pipeline, and release pipeline is creating a service connection to any third party service like Microsoft Azure, GitHub, or and deploying our artifacts to any third party provider via service connection. So this deployment process is called continuous deployment or delivery. So I hope you guys understood. Now we will see a build pipeline setup. So this is the structure how we are going to set up our build pipeline. First we will push our code to Azure Repos. Second we will check out our code from Azure Repos to build pipeline. And third we will store and publish artifacts. So stay tuned. So guys, now I am on my Azure DevOps project 1. So I will create a new repo and try to push my code from local system to Azure Repos. The code I will provide you on my GitHub link, so you can go and clone that repo. I will go to Azure Repo. I will create one new repository. I will name it as Hello World React Application. I just click on create. Now you can see my Hello World React Application repository has been created. I will clone this repository. Now I will open my Git bash. So if you guys are confused or not getting anything, just go to my previous video. I have explained everything in depth. So I will just give the command git clone and the URL. So you can see it is cloning. Now we can see our repo is empty. Now we need to add some code. I will copy this code from here and paste it here. Now we will go to hello world folder and do git add all. Now git commit -m first commit. I will do git push. Now if we will refresh our pen, we can see our code here. See our code has been pushed successfully from our local system to Azure Repos. Now moving ahead, now we can click here on setup on build to create our pipeline, or we can go to pipelines. We can create a new pipeline. First we have to select our code. So we will select Azure Repos. I will select my repo. This is my repo. So we can see that Microsoft Azure DevOps has analyzed our code and it is giving us this many options to build our code with Node.js and React. So I will select this option because our project is Node.js with React. You can see this is the default generated YAML file created by Microsoft Azure, but we can configure this with our own purpose. So now first you can see the trigger is our main branch, then pool, it is selecting Ubuntu data as the default build agent for this job. Then the steps is to first, then we can see the steps. So the first step, as you can see, is to install the Node tool. That means it is installing Node.js software to our build machine. As I have installed Node.js to my local system in previous video, I have told you this. So it is installing Node.js into its build machine. So you can see the input parameters. The version it is installing is 10x, and the display name is install Node.js. So we have to do some changes. So our React application is the latest version, so we can change it to 16x. Now we can see the second task it is doing. It is executing some scripts like npm install and npm run build. So these two commands I have told you in my previous video. We have run these commands in our local system to compile our Node.js application. So before this, we will see that what files are being generated before compilation of code and after compilation of code. So I will give the script before npm run build, and script will be echo build viewing files before compilation we have to give this. If we are running multi-line scripts, then I will give second command or script at ls build dot sources directory. So guys, if you are not familiar with this variable, so you can check it out my previous video. I have explained these things in depth. So this command will help us to view our files before compilation, and same we will do after compilation. Copy this command, and I will give viewing files after compilation and build.source directory. I will provide a display name. Display name will be viewing before build, and the second one will be after build. Now our code has been completed. Now we will run this pipeline. We can see the jobs. It will take a while. So we can see first it is checking out our code from Azure Repos to its builder machine. It is installing Node.js, Node 16. Then we can see the file before build. So these are the files before building or compilation of our code. We can compare these files with our Azure Repos files. We will get the same number of files here also and here also. So there is nothing new here. Then it is executing the commands npm install and npm run build, and it is compiling our code, and we can see after build node modules and build folder is generated. We can compare it again. Before build we don't have these two files, and after build we have build and node modules. So node modules, as I mentioned earlier in my previous video, node modules, it contains all the packages and dependencies to build our code. Then build folder contains the static web page or static files. It is also the artifact folder. So our job has been done here. Now we will move ahead and we will see how we can store our artifacts into a separate folder and publish them into pipeline. We will again go to pipeline. Before that we should rename this pipeline. Pipeline. We'll again edit our pipeline. So we know that we need the build files because the build files contains our artifacts. We will give a task. So this panel is a task panel. Here Microsoft has predefined many tasks. So you can go and just click on the function and you can use it in your pipeline. So I will search one task called copy files. So I will just click on copy files task, and first I will give the source folder. So this is my source folder, Control C, and in that we have to go into build folder. I will copy all the contents. Star means all the contents, and target folder will be artifact staging directory. So the copy file task will do what? I will tell you. Just click on add, and you can see the code has been pushed here. So the task is copy file, and it is doing what? It is copying the files from build.source directory, and in that, from build folder, it is taking all the contents and copying into a separate folder called build.artifact staging directory. Guys, again, if you are not understanding these variables, then check it out my previous video. I have explained everything in detail. So now our build files or artifacts has been copied from source directory to artifact staging directory. Now we will move this or publish this artifact to our pipeline so we can see it. We are copying our artifact from source directory to staging directory. Now moving ahead and publishing this artifact to our pipeline. So we can go. We will again search one task, publish, and we can see we are getting one task, publish build artifacts. We will click on this. So it is already taking my artifact staging directory, and it is creating an artifact named drop, and it is publishing to Azure pipelines. So we will click on just add, and we can see publish artifact task has been successfully inserted to our pipeline. So what does it will do? I will explain you once again. It will take our artifact from this folder and it will publish it to our pipeline in a container. I will show how we can physically access that container and see our artifacts. So now we will run our pipeline and see what happens. It will take a while. It is checking out our code, installing Node.js. Then we can see the files before build. It is just compiling our code with npm install and npm run build command. It will take a while. So we can see it had compiled our code, and after build we can see we have built a node modules folder here. We don't need node modules as of now. We only need build. So we are copying build from this folder to a separate folder. We can see copy file task is copying all the build files to a separate folder called artifact staging directory. This is the path of that directory, and it is publishing the artifacts into a container. We can see, and the job is finished. We can go and check it out, our container, and if the artifact has been pushed or not. Click here, click on the latest pipeline. We can see related one work item is published right now. Click here, click on the artifact name, the container name, and we can see these are the build files that we have published to a container. So in next video we will see how we can take these build files or artifacts to a release pipeline and deploy it to. So previously we have seen how we have created a build pipeline of React.js application and published our artifacts. So now we will see further how to take that artifact and create a release pipeline and deploy it to an Azure app service. So before moving ahead, I request you all to like and subscribe my channel. First we will see today's agenda. We will see what is service connection. Then we will see Azure web apps. At last we will see deployment of React application in release pipelines. service connection. So service connections in Azure DevOps are used to connect to external services and platforms such as Azure subscriptions, GitHub repositories, Docker registries, and many more. They allow your pipeline and releases to interact with and deploy to these external services. So this is how we are going to create a service connection between our Azure DevOps and Microsoft Azure. You can see in the diagram, in left side we have Azure DevOps and in right side we have Microsoft Azure, and in between there is service connection, which is a communication or a bridge between Azure DevOps and Microsoft Azure, so that Azure DevOps can communicate with Microsoft Azure. So we will see service connection in action right now. So team, I am in my Azure DevOps org. Now to create a service connection, first you have to create your Microsoft Azure account. So I have already created a Microsoft Azure account. I will be using that. For service connection, you have to go into project settings. Then in left panel you can see there is service connection. You have to click here. You have to create your first service connection. Click on this. You can use Docker, GitHub, Jenkins, or you can integrate any third-party application to your Azure DevOps. We are using Azure, so we will use Azure Resource Manager, also called as ARM. Click on next. So these many options are here. We can give our service connection details manually, or we can just take it automatically by clicking it here. Click on next. You can see it is loading my Azure subscriptions. So you can see guys, my subscriptions are listed here. This is my default subscription, so I have selected this one. We have to select a resource group. I will select lab 1. We have to give service connection name. Name can be anything. Azure SVC I will give. You can give a description if you want. We have to click grant access to all pipelines. Just save it. And you can see our connection has been setting up. So now our service connection has been created. Let's move ahead. Now we will see what is Azure Web App and how to create it in Azure. So first we will see the definition. So Azure Web App refers to a service provided by Microsoft Azure, a cloud computing platform. Azure Web Apps, now part of Azure App Service, is a fully managed platform for building, deploying and scaling applications. It supports multiple languages and frameworks including .NET, Java, Node.js, Python and PHP. So it is like a ready-made cloud computing platform which can host your applications very easily. Just you have to release your code or your artifacts to Azure Web App and your site is online and ready to use. So you can see we will follow this strategy now to deploying of our application from release pipeline to app service. So the first 3 steps we have covered in our previous video. Now we will see how we can take our artifacts, move it to release pipeline and then publish it to an app service. Let's move ahead. Now we will create an web app or app service in Azure. So now we will create app service. Click on create web app. We have to select our subscription resource group. I am selecting my existing one. App service unique name, React app 1 2 3 4. Publish will be code. Okay, it is not available, so app service name should be unique. I think this is available. Now we have to select publish. Publish type can be code or Docker container or static web app. As of now we are using code. We will select runtime stack. So our app is of Node.js based, so we will select Node 18. You can select a version according to your project. Operating system, I will select Windows. You can select Linux also. Region is fine for me. So pricing is free. That's good for me. Now I will skip all these specification. I will just click on create and I will create it. So you can see our app service is being created. So our deployment is in progress. So this is our app service. You can click on browse and see your web app is running and waiting for the content. Now we will see how we are going to deploy our React application in Azure release pipelines. So once again, I am in my Azure DevOps account. Previously, we have seen how we have created our build pipeline and published our artifacts to pipeline. So you can see this is our container and these are our artifacts that we are going to use in our release pipeline. So we will go to releases and you can see it is saying so no release pipelines found. We will create a new release pipeline. Click on new pipeline. It is saying to select a template, but before this we have to do some configurations. This is the structure of release pipeline. You can give your name to your release pipeline. React app release pipeline. Now in pipeline section, you can see you have to add artifacts in your first stage. So you can click on add an artifact. You can select your artifact from these many services, but for this project we are selecting our artifact from build pipeline. If you click on build, we will select our project and then the pipeline name. This is our pipeline. We will select this and you can see it is saying which version you want of your artifact. We will select latest, click on add and you can see our artifact has been added. Then we have to add stages to complete our release pipeline. We will click on add a stage. We can select any predefined template or we can select an empty job and create our own template. So we can change the name of stage, deployment. I will rename it to deployment. Next, we can click on view stages and tasks and you can see these many options I am getting. So in deployment it is saying the name of my stage. Then click here and you will get the configuration of your agent or your build machine your in which your background task will be executed. You can see it is saying display name and you can see here we are selecting our build agent. So we can select our self-hosted agent or Azure Pipeless agents. As of now we are selecting Azure Pipeless agent and we can give specification of our build agent. We will select Ubuntu latest as our build agent. Now we will add one more job and in the panel we can see we are getting this many options. We have to deploy our artifact to an Azure web app. So we will select Azure App Service Deployment. Click on this and you can see Azure App Service Deploy. We have to do some configuration in this task. So display name we can change it or we can leave it as it. Connection type is Azure Resource Manager. It is correct. We have to select Azure subscription. Then we have to select app service type. Mine is web app on Windows. It is good for me. Now we have to select the app service name. So this is my app service name. Now we have to select our artifact folder. Click here and we have to select this drop container. So I've already selected this. So now just click on save and create release. As you can see, release 4 has been created. Click on this. You can see our deployment is queued. Now it will start. It is in progress. You can see logs also. Click on this. So agent is running our job. It is downloading artifact from build pipeline, and now it is deploying our artifact to app service. It will take a while. And now you can see our job has been completed and our release pipeline has been succeeded. Now you can go to your web app and check our application is hosted or not. So this is my application. I will click on this and I may click on browse. Make sure your app service is running. And you can see our app service has been deployed successfully. So this marks an end to this chapter. So previously we have seen how we have deployed React.js application on Azure pipelines and deployed it to an Azure app service. Now in today's video we will see how we can compile a Spring Boot application and deploy it to Azure pipelines. So we will see first today's agenda. First we will see strategy of deploying an Java Spring Boot application. Second, we will see local compilation and deployment of Spring Boot application. At last, we will see Azure Pipelines compilation and deployment of Spring Boot app. Strategy of deploying a Java Spring Boot application. A Java Spring Boot application is a web application built using the Spring Boot framework, which is a part of largest Spring framework for Java. Spring Boot simplifies the process of creating standalone, production-grade, Spring-based applications. It offers a wide range of features that help in rapid application development. So this was the definition of Java Spring Boot app. Now we will see how we are going to deploy our Java Spring Boot app to Azure pipelines. So you can see in below image. First, Azure Repos contains our Spring Boot application. Then second, we will fetch the code and check out it to build pipeline, and we will create a YAML file. We will build our code and we will generate artifacts. The artifacts will contain jar or var file. We will then create a release pipeline and take our artifacts, jar or var file to release pipeline and deploy it to app service. So if you are not familiar with what is app service or release pipeline, then please check out my previous video. I have explained everything in details. So first we will see local compilation and deployment of Spring Boot. So guys, now we will see how we are going to build Java Spring Boot application in our local system. So I have already downloaded the sample code of Java Spring Boot app. I will provide GitHub link of this code in the description below. So let's move ahead. So the prerequisite to build a Java Spring Boot app is that first you need JDK or Java, and second one you need Maven to be installed in your local system. So we will fulfill this prerequisite. First we will install Java. So now first we have to install Java, JDK, download. We have to go to the first link, accept all, and now you can install JDK from this website. Click on Windows section and download the installer. So our download has been completed. Now we have to open this file and we have to install JDK into our local machine. Click on next. Just leave all the settings at default. So you can see our Java has been installed successfully. Now we have to install Maven in our local system. Let's do it. Go to your browser. Navigate to Google. Search for Maven or Windows. And you can click on the download section. So you can click on this binary zip archive. So you can see our Apache Maven has been downloaded. So this is our Apache Maven. We have to extract this. After extracting this, we have to copy the folder Apache Maven. Go to program files. See program files. Just paste it here. After that, you have to configure the environment variables. Go here, search environment variables, click on this, click on environment variables section. So here we have to add two environment variables. First is of Maven home and second is its bin path. Go to the folder, go to the bin directory, copy the bin path, go here in system variables, go to the path section, create a new path, add the path here, click on OK, and now our bin path has been added. Now we have to add Maven home. Click on new, type Maven home, go back to Apache Maven. We have to copy this path of Apache Maven and paste it here. Click on OK, OK, and OK. Now we have to verify that our Maven and Java has been installed or not. Open command prompt, click here. Now type Java --version, and you can see Java 21 has been installed. Now mvn -f version. So you can see Apache Maven has also been installed in our local system. Now we are ready to build our Java Spring Boot application locally. So as you can see, I have my Java Spring Boot application here on my desktop. Now I will navigate to desktop, to dir, cd and desktop. Click enter. Now you can see I am in my desktop in my terminal. To list all the files, click on dir. So you can see I have Java Spring Boot directory. Once more, I will give cd Java Spring Boot app. Click on this. I will check all the files by going dir. Now you can see all my files have been listed here. You can go here and see that the same files has been listed here in my terminal also. So now we will try to run this app locally. So for running this app locally, we have to give command mvn install. Make sure you are in the correct path where your app is available. Just click enter, and you can see Maven is building our file locally. It is downloading all the dependencies to build this file. It will take a while and it will generate a target folder here. You will analyze that a target folder has been generated in this application folder, and that target folder contains our jar file or var file which will be deployable. So you can see our target folder has been generated right now, and it contains our artifacts that will be deployed. So you can see our build has been success and our artifacts has been generated. We will navigate to target folder and see. So we can see we have got our snapshot.jar file. So this is the main artifact or the executable jar file which will be hosted to our web page. Now we will navigate to this target folder in our terminal. Let me clear my screen. Now, once again I will do dir. I will go to target and I can see all the files in my terminal also. So we can see our Spring Boot application is here in terminal also. Now we will run the command to run this jar file. The command to run this jar file is java-jar and Spring Boot snapshot.jar file. Click on enter. Now you can see our Spring Boot is running. Click on allow access. So you can see it is saying that application has been started on port 8080. Now we will go to our browser and see and type localhost 8080.
So guys, we have to give the URL localhost column 8080 slash hello and we will get our web page. So you can see it is printing out hello world. So our application is up and running. So now this is the end of our local compilation of code of Java Spring Boot application. Thank you.
So now we will see Azure Pipelines compilation and deployment of Spring Boot application. So guys, I am in my DevOps organization. We will go to Azure Repos. So I have already pushed my code to Git repos. I will provide the GitHub link of this code. So we can see we have these files source, git ignore, pom.xml and readme file. So pom.xml is a main file which has all my configuration to create our Java word file. Now we will move ahead and see how we can create a pipeline and compile this code. We can click on setup build. And now you can see our Azure DevOps has analyzed our code and given us these options. It is saying that our project is based on Maven, so we can click on Maven and choose a Maven template. I will select the first one. You can see it has given me these options. So in steps you can see. So this Maven at the rate 3 task installs Java or JDK in our build machine, that is a Ubuntu machine, and do the Maven install command behind the scene. You can see it is taking our pom.xml file and selecting all our configuration to create our jar file. It is installing a JDK of 1.8 and we have already skipped the test result and the goal is to package. That means it is doing Maven install behind the scene. We can give a script to see what is happening and what files are being generated behind the scenes. ls. I will give a display name, view files after build. Now we can save and run this and see what happens. So we can see Maven is compiling our code. It is downloading the dependencies from central repo and compiling our code. This thing we have seen in our local compilation also. So it will take a while. So we can see our pipeline has been ran successfully. We can view the files, our compilation. We can see target folder has been generated and we already know that in target folder we have our build file or artifact as jar or word files. In our case, it is a jar file. Now we have seen that our Spring Boot app has been successfully ran and created the artifacts. Now we will publish the artifacts. We will go again to our pipeline. First, let me rename this. I will give pipeline at the end of this. I will click on edit. Now we have seen that our target folder has been generated. Now we will publish our artifact to pipeline using publish artifact task. So I will just remove this step and create a copy file task. Our source folder will be build dot slash target and contents will star dot jar and target folder. Now I will add this to our pipeline. Now it will take our jar file from this target folder and copy it to artifact setting directory. Now we will publish this artifact to our pipeline. We will use publish artifact task. We will click on add. And now our code is completed. Now we will save it and we can see our pipeline is running. So now we can see our job has been finished and artifacts has been published. We can go to pipeline and check it out. So you can see our jar file has been published. Now we have to release the jar file to an app service. So before releasing it to a app service, we will create an app service. Now we will go to portal.azure.com. We will search for app service. We will create a new app service. I will provide a resource group, a name, Java Spring Boot 1 2. Publish will be code. Runtime stack will be Java 17. Java Web Server Java SE. Good for me. Now we have to keep these settings or configuration while creating a web app for Java Spring Boot application. If you will change this configuration, then your application might not work. I will just review and create. Click on create. Now we can see our deployment has been completed. I will go back to my Azure pipelines and create a release pipeline. I will click on releases. I will click on new pipeline. I will provide the basic configuration. Spring Boot release pipeline, the name of the pipeline. I will add the artifact. I will select Java Spring Boot pipeline. Click on add. I will add a stage. I will select a predefined template from here. Deploy your Java app to Azure App Service. Click on apply. Deploy to app service. Now I will see the task. I have to select my Azure subscription. Our app type is web app on Linux. I will provide my app service name Java Spring Boot 12. Now we have to keep in mind that our artifact is of a jar file instead of word file. So I will disable this war file task and I will enable the jar file task. So we can see our basic configuration of releasing our jar file to app service has been done. I will just save it, click on release, and we can see our release one has been created. So our task is in progress. So now we can see our job has been done. We can go to our app service, click on browse. So you will get this white label error page. Don't be scared. Just click here and type /hello and you will get your deployment. You can see our web page is online. In previous video, we have seen how to build and deploy a Java Spring Boot application. I hope you have enjoyed my previous video and you have gained an understanding of how to create and deploy Java Spring Boot application in Azure pipelines. In today's video, we will see how to create an Azure Classic pipelines and we will deploy the same Spring Boot application in Azure Classic pipelines. If you haven't seen my previous video, then go back and check. It will create a basic understanding how Spring Boot application is deployed using Azure pipelines. After that, see this tutorial and it will give you a great understanding of how pipelines work in Azure. So we can see this is the template of Azure YAML pipelines. We have already worked on this and we are familiar with this pipeline syntax. Now we will see Azure Classic Pipelines. This is the syntax of Azure Classic Pipelines. As you can see, it is a GUI based pipelines and you can easily get your pipeline job done. We are dragging and dropping tasks. It is easy to use for beginners. The graphical interface provides a clear visual representation of pipeline flow. Now we will see Azure Classic Pipelines hands-on. So guys, you can see I am in my DevOps organization. So I will use my previous code of Java Spring Boot application. If you don't have this code, then I will provide you the GitHub link of this code. And you can see my previous video. I have deployed this Java Spring Boot app using Azure pipelines. Now we will move ahead and do the same deployment of Java Spring Boot app using classic pipelines. So for classic pipelines, we have to go to pipeline section. We have to click on new pipeline. Here you can see it is asking that where is my code. Instead of selecting Azure Repos or any third-party provided repo, I will click on Use Classic Editor. After that, it is saying to select my repository. I will select Azure Repos Git Project 1, Hello World Spring Boot app, and the branch is main. I will click on Continue. Now it is saying to select a template, or I can select an empty job and create my own template. But instead of creating my own template, I will select a predefined Maven template. Click here on Maven and apply. So you can see it has given all the tasks related to Java Spring Boot application. You can see the tasks are Maven pom.xml. That is, it is taking my pom.xml file and
building my Java Spring Boot application, and its main goal is to package. That means to compile my code and create a jar or POD file.
so in second task you can see it is copying my artifact that is in the jar file. It is copying from my source directory to artifact staging directory. At last you can see it is publishing my artifact to pipeline container. So these steps we have already covered in detail in my previous video using YAML template. If you are not getting anything, just go and check it out. So I just need to add agent specification of build machine. I will select Ubuntu latest. You can select any machine of your choice. Now I will save this so you can see that how easy it is to create a CI/CD pipeline using Azure Classic Pipeline template. And if you are interested in the YAML code of this task, you can click here and view YAML code also. And you can see by clicking on YAML, I have got the YAML code of this Maven task. Similarly, you can click on copy file task and view the YAML code. As you can see, the step we have performed in earlier in our pipeline, the copy file task, it is taking the source directory and copying the jar file to artifact staging directory. The same you can see a publish artifact. You can see the YAML code. The task is publish artifact. It is taking the artifact staging directory and publishing our artifact pipeline container. We will just save this pipeline and click on queue, and we will run this pipeline. And you can see our pipeline is running. So you can see our pipeline has run successfully and all job has been done. Now we will go to pipeline and see if our artifact has been published or not. Click here and you can see the container of artifact. Click on target and you can see our jar file has been published. Now we will create a release pipeline. Click on releases. So now we will create a new Spring Boot release pipeline. Click on new. This time I will again select deploy to Java app to Azure App Service template. Click on apply. But first we need to add our artifact. Click on add an artifact. Select our project 01 Maven CI. This is our new pipeline or classic pipeline. We will select these settings at default. Click on add. I will click on stages. I will disable this var file deployment because our artifact is of jar file, and I will enable jar file deployment. So we can see we need to add some basic details like Azure subscription and app service name. So I have already created an app service. You can check my previous video of creation of app service for Java Spring Boot application. This is my app service. You can see the configuration. You can see I am using Java 17 and Java Web Server as my configuration of this app service. I will go back. I will select web app on Linux. I will provide the app service name. I will save and create a release. So you can see release 1 has been created. I will provide a name for this pipeline. And we can see our job has been done. We will go to app service, click on browse, and we can see we are getting white label error page. Just give slash hello in the URL and you can see. So in previous video we have seen how we have built and deployed a Spring Boot application in local as well as in Azure pipelines. In this particular video we will see how we will build and deploy a .NET project in local system as well as in Azure pipelines. So let's get started. First we will see our today's agenda. We will see how we are going to build a .NET application in our local system. And in second we can see how we can build and deploy a .NET application on Azure pipelines. At last we will see how to build a .NET application with Azure Classic pipelines. First we will see how to build a .NET application in local system. Now we will see how we can build a .NET application in our local system. I have already downloaded .NET code in my local system. This is the sample Hello World application of .NET. I will provide GitHub link of this application in the description below. So for this particular .NET application, we need to install .NET framework in our local system. We have to go to our browser. So for our project, we need .NET 7. We need to type .NET 7 download. We have to click on first link and we can install .NET 7.0. Mine is Windows, so I am installing .NET 7.0 Windows installer. So you have to keep in mind you have to download .NET 7.0 for this particular project because this code is based on .NET 7.0, and if you will use a higher version like .NET 8, then this project will not work. My file has been downloaded. Now I will open this file. I will just click on install and you can see our .NET Framework 7.0 is being installed. It will take a while. Now our .NET 7.0 has been installed successfully in our local system. I will close this installer. I will go back to my desktop. I will open my project folder and you can see I have these files in my .NET code. I will go to .web folder. We can see we have many folders like controllers, models, object, properties, views and www root. So in order to build our .NET project, we need to open our terminal or command prompt. To check the version of .NET, we can give command .NET -- version. We can see we have installed .NET 7.0. Now we will navigate to our project folder. I will go back once and I will copy this path. I will navigate this path into my terminal. Click enter and we can see we have the same files that is present in my folder as well as my terminal. Now in order to build .NET code, we have to give .NET build command, but before that I want you to see what files or folders are being generated after compilation of our .NET code. I will go to my .web folder and you can see we have these many folders as of now, but after giving .NET build command, you can analyze that one folder will be generated and that folder will contain our artifacts or build files. I will click on enter. and you can see a bin folder has been generated right now. We can see our build has been succeeded and bin folder has been generated. Now we have to go inside the bin folder. We can see we have these many files, but the main executable or but the main artifact of our .NET project is .dll file. As we have seen in our previous video of Java Spring Boot application, we have artifact in form of .jar or war file, but in .NET we have artifact or the main executable file in the form of .dll. So we have to run this .dll file. I will navigate to this folder or path cd. I will provide the path. Now we can view all the folder or files by giving dir command. We can see we have access to our DLL file in our terminal as well. Now we will give .NET hello world app.web.dll. Click enter and you can see our application is running right now and it is available on localhost 5000. I will copy this, go to my browser and paste the URL, click enter, and you can see our hello world.net application is up and running. So this was the local compilation of .NET application. Now we will see the same in Azure pipelines. Now we will see how we can build and deploy a .NET application on Azure pipelines. Now we will build our code in Azure pipelines. We will click on setup build and we can see we are getting this predefined template provided by Microsoft Azure as part of our ASP.NET project. We will click on first template and you can see we have been provided a YAML file generated by Microsoft Azure. I will delete all the comments. I will explain this YAML file to you. So in first we can see trigger is to main branch, that means it is taking our main branch. Then in pool section we can see we are using a Windows machine as its build agent. Then in third we can see we have some variables. So the first variable is solution and it is taking our .sln file, and if we go to our Azure repos we have one hello world app.sln file and it consists of all the configuration. Then second variable is build platform and its value is any CPU, that means it is taking any CPU to build our code in the platform. Third variable is build configuration and its value is release. Then in steps we can see the first task is NuGet tool installer @1. So this task will install NuGet tool to our build machine and it will be used to compile our code. Then the second task is NuGet command @2 and it is taking input restore solution and it is taking our solution variable, and the solution variable is pointing to .sln file, that means NuGet command @2 is taking our this .sln file and it is restoring the solution. Then the next task we can see vs build @1 and we can see the properties of this task: Visual Studio build with MS build, and set the Visual Studio version property. That means this task is used to build or compile our code. We can see it is taking our solution file, that .sln file, and in MS build args it is doing some task like deploy on build is equal to true, web publish method package as single file true, that means our all the build files will be packaged as single file. Next we can see skip invalid configurations true, and then last it is doing task package location, that means it is building our package in previous all this task and packaging our artifact to artifact staging directory, so we don't need to create another task and copy our build files from source directory to artifact staging directory. In this vs build task, it is already doing that thing, and after that we can see it is running some test cases, so we can skip these test cases as of now. And we already know that this vs build task is building or compiling our code and copying all my artifacts to build.artifact staging directory. So we only need to publish our artifact to pipeline. We will give the task publish artifact, click enter, and now we will save and run this pipeline. Now we can see our pipeline has been ran successfully. We can see publish artifact task has also been done. We can go to pipeline and see whether our artifacts has been published or not, and we can see all our artifacts has been published, and there is a zip folder in which our main DLL file consists. We can see also we can download this zip file, and we can see our all artifacts included in .dll file is available here. We can close this, and now our build pipeline has been completed. Now we have to release this artifact to an app service. So first we will create an app service for our release pipeline. I will go to Microsoft Azure portal and create a web app. I will provide a resource group, web app name. I will choose runtime stack as ASP.NET 7 because our project is based on ASP.NET 7 as I have stated previously. I will choose the pricing as free. Now I will review and create this scene. This is our app service and it is running, and its configuration is .NET 7.0. Now we will push our artifact from release pipeline to this app service. I will go to releases, create a new release pipeline. I will name it as .NET release. I will add artifacts. I will select my project and my pipeline. Click on add. I will add a stage. I will select predefined template as our app service deployment. Now I will view the task. So now I have to give basic configuration details like my subscription and app service name. Now I will provide our app service name. I will go to deploy Azure App Service task. I will scroll down. I will just save this pipeline and click on create release, and we can see release 1 has been created. And we can see our task is in progress. It will take a while to deploy. And we can see our deployment has been completed. We can check logs also. Now I will go to my Azure App Service, click on browse, and we can see our app service is been running and hosting our application. So we can see that how easy it is to deploy a .NET application in Azure pipelines. In this topic, we will see how to build .NET application with Azure Classic Pipelines. So this is our .NET application. To build a classic pipeline, I will go again to our pipeline section. I will click on new pipeline. Now this time I will use classic editor to create a pipeline without YAML. I will select my repository. I will select a predefined ASP.NET template for this project. I will select this task ASP.NET Core. Click on apply. And we can see I have got all my tasks without any code. I will just rename our pipeline name. Now we can see it is restoring our solution. It is building our code and running some test results, but we don't need this as of now. I will remove this task, and after build we can see it is already publishing our artifact to artifact staging directory, and it is publishing our artifact to pipeline also. So we don't need to add any further tasks. We only need to add some basic details like agent specification. That means which agent you want to use as your build machine. I will select Windows. I will just click on save, and I will run the pipeline. So if you are a beginner or new to Azure DevOps, you can see how easy it is to create a pipeline with the use of Azure Classic Pipelines. You don't have to see any code. All the codes are behind the scenes of Azure Classic Pipelines, and you have to only drag and drop the tasks. So we can see our pipeline has run successfully and all jobs has been done. We will go to pipeline and check if our artifact has been published to pipeline or not. So this is my classic pipeline, and we can see one file has been published. We can click on the drop container and we can see our zip file has been published, and the zip file consists all my artifacts and the DLL file also. And now we can do the same. We can create a release out of this pipeline and release our zip file or our artifact to an Azure app service. So I hope this session was fruitful for you and you got an understanding how to build and deploy an .NET application in local machine as well as in Azure DevOps. So thank you guys. In some previous video we have seen how to build a .NET application, React.js application and Java Spring Boot application. In this video we will see how to build and deploy an Angular application in local system as well as on Azure pipelines. So let's get started. First we will see today's agenda. We will see the prerequisites to build an Angular application. Then we will see how to build an Angular application in local system. At last we will build and deploy an Angular application on Azure build pipelines. So first we will see the prerequisite to build an Angular application. The tools used to build an Angular code. First one is Node.js, and second we need Angular CLI. Then commands to build an Angular application. First npm install. It will download all the packages and dependencies required to build this code. Second, ng build command. This command will build our code and generate build files. At last, ng serve or npm start. These commands will host our application in local system. Now we will see how to build an Angular application in local system. Now we will see local compilation of our Angular application. So I have provided the GitHub link of this Hello World Angular application in the description below. You can go and check it out. First, we need to fulfill our prerequisites. We have to install Node.js and Angular CLI in our local system. I will go to my browser. I will search for Node.js. I will click on the first link. I will download the LTS version. And now I will install this file. Just leave all the settings as default and install the tool. So our installation has been finished. Now we need to install Angular CLI. Go back to Google. Search for Angular CLI installation. Click on first link. And these are the steps to install Angular CLI in local system. I will open my command prompt. I will copy this first command, paste it in my command prompt, click enter, and we can see Angular CLI is installing. Now our all packages of Angular CLI has been installed. Now we will verify our installation. I will give ng version and you can see we have Angular CLI version 17 and Node.js version 20. Now all the build tools has been installed. Now we will build our code. I will go to my app. So this is our application. I will open command prompt here. Now, so we can see I am in the same path of my code in my terminal. I will give dir and we can view all the files here. Now we need to give the first command, that is npm install, and node modules folder will be generated here. We can see node modules has been generated. So npm install will install all the packages and dependencies to build our code. And we can see our command has been executed successfully. Now it's time to give our second command. We need to build our code. For that we will give ng build command. It will build our code and give us a .dist folder, and in .dist folder we will have our build files. We will see this. So we can see here, so first .angular folder has been created and we can see our dist folder has been generated, and in this dist folder we have this our build files or artifacts. In browser we can see we have our index.html page and all the artifacts. Now we need to serve or host our application into local browser. I will give the last command ng serve or npm start. So I will give ng serve this time. Make a note that ng serve will also generate your build file and host your application, but instead of that I have done ng build command to build our static files, then ng serve command to host our build files or host our application. Now we can see our application is hosted on localhost 4200. I will open any browser. And we can see our Angular Hello World application is running. So now we will see how we can build and deploy this Angular application in our Azure pipelines. So we can see I am in my Azure DevOps organization and I have already pushed the Hello World Angular application to my Azure Repos. Now we will create a CI/CD pipeline using Azure pipelines. We will click on setup build. So I have provided the GitHub link of this code in the description below. Now to create a pipeline out of it, we have to click on setup build. Now our application is Node.js with Angular, so we will select this template. I will remove the comments, and we can see this is the default generated YAML file for an Angular code. So triggered is main, it is taking our main branch from our repo. Then in pull section we can see it is using an Ubuntu machine as its build agent. In steps we can see it is performing node tool installation. We have to keep in mind that it is using a lower version. We should at least use version 18, otherwise it will generate an error while compilation because our application is based on node 18 or higher. In script we can see the first script is to install Angular CLI, and these two steps we have seen in local compilation also. We have installed Node.js and Angular CLI as our build tools. Now the same commands we have run also in our local compilation, npm install and ng build. So ng build we will delete hyphen prod, we will give only ng build. So npm install will install all the dependencies and packages for our code, and ng build will build or compile our code and generate build files in dist folder. So these things we have seen thoroughly in our local compilation. Now after this we already know that a dist folder will be created, and in that we have a hello folder, and in that folder we have our build files. So we need to copy the build files to our artifact staging directory and then push those artifacts to an Azure app service. I will give copy file task. I will give the source folder, build our sources directory, and in that we have to go inside this. We have a subfolder hello world. We have to go inside hello world folder and we will get our artifacts. I will copy all the contents to artifact staging directory. Now I will click on add. So it will copy my artifacts to a separate location. Now if we want, we can push the artifacts. I will use published artifact task. I will click on add. So it will take my artifacts from this folder, artifact staging directory, and it will publish it to a container named drop in our pipeline. Now in this project we will not create a separate release pipeline. We will do releasing process also in this build pipeline. I will show you how we can do. But before deploying our application to an app service, we need to create an app service. So we will see how we are going to create an app service and what will be its configuration to deploy our application. So now we will see how to create Azure web app for this deployment. First we will go to portal.azure.com and we will sign in to our Microsoft Azure account. After that we will search for app services, then click on create a web app. So I will provide the basic details to create our app service. We have to select our subscription resource group. I am selecting my existing one, app service unique name, React app 1 2 3 4. Publish will be code. Okay, it is not available, so app service name should be unique. I think this is available. Now we have to select published type can be code or docker container or static web app. As of now we are using code. We will select runtime stack. So our app is of Node.js based, so we will select Node 18. You can select a version according to your project. So in operating system I will choose Linux for this web app. So pricing is free. I will skip all these specification. I will just click on create and I will create it. So you can see our app service is being created. So our deployment is in progress. So this is our app service. You can click on browse. Now our app service has been created and it is up and running. Now we will go to our YAML file and we will add our app service for deployment of our application. Now I am back in my YAML file. Now I will add our app service here. You can see this is the task Azure app service deploy, and we can directly deploy our artifacts to the app service from our pipeline using this app service deploy task. We don't need to create a separate release pipeline. So it is asking some basic details like subscription. I will select our app type. Our app is on Linux. I will select the app service name. Now in artifact folder I will give this build artifact staging directory because my artifact is been here. I will click on add. Now we have done all the things, so I will explain once again this to you. We are installing the tools to build our code like Node.js and Angular CLI. Second, we are building our code by ng build and npm install. After that, we are copying our artifacts from this folder dist/hello world to a separate folder artifact staging directory. And after that, we are publishing our artifacts to our container so that we can see our artifacts in our pipeline container. After that, we are deploying our artifacts to an Azure web app service. Now I will just save and run this code. So you can see it has installed Node.js in our build machine. Now it is installing Angular CLI and the commands npm install and ng build it will perform. So now we can see till publish artifacts the job has been done. Now it is deploying our artifacts to Azure web app. So we can see all our job has been done. I will go back to my pipeline. I will open my pipeline, and in artifacts we can see our artifacts has been published. These are our artifacts, and in browser we can see our index.html page. Now our deployment is also been completed. I will go to my, so this is our app service. You can click on browse and we can see our application has not been hosted. I think it will take up to 5 minutes for our content to show up. So instead of that, I can go to advanced tools, click on go, and we can see we are in the control panel of our app service. We can access all the files and everything of our app service from here. Now to access our app, we can click on site www root. We can see the published artifacts are here: browser server, third-party license, and pre-renders routes. Now I will click on browser and we can see our application has been hosted to app service. So our index.html page is in the browser folder inside the artifacts. So I have clicked on the browser folder. So after clicking on browser folder, we will get our artifacts. So this is the URL of our web page. So This was the Azure Pipelines compilation of our Angular application. So this marks an end to this chapter. I hope you guys have understood all the things very clearly and you got to learn something new. We have already seen how to build and deploy a .NET application, a React.js application and Java Spring Boot application in our previous video. If you haven't seen those videos, go back and check it out in my Azure DevOps playlist. In this particular video, we will see how to create a self-hosted agent in Azure DevOps and use it in our Azure pipelines. So let's get started. We will see our today's agenda. First, we will see what is self-hosted agent in Azure DevOps. Next, we will move on to how to create a self-hosted agent. First, we will see self-hosted agents in Azure DevOps. In Azure DevOps, a self-hosted agent refers to a machine or server that you set up and manage yourself to run jobs or tasks in your pipeline. Unlike Microsoft hosted agents, which Azure DevOps provides and manages for you, self-hosted agents are under your control. They can be physical or virtual machines, and you install and configure the necessary software tools and dependencies on them based on your project requirements. So, using self-hosted agents offers several advantages. First one is customization. You can tailor the agents to meet your specific needs by installing software tools and libraries required for your builds and deployments. Security and compliance. Since these agents run within your own infrastructure, you have greater control over security configurations, compliance standards, and access controls. Performance and isolation. You can optimize the performance of self-hosted agents based on your hardware and network capabilities. Additionally, you can isolate sensitive or critical builds from your shared resources. So now we will see how to create a self-hosted agent. So to configure an agent, we have to go into our Azure DevOps organization and in organization settings, and now scroll down a little and under the pipeline section you can see agent pools. Click on agent pools. We can see we have only two agent pools as of now. First one is Azure pipelines. So this is the default build agent provided by Microsoft Azure, and second one is the default pipelines. We can go to default, click on agent, and we can add our first agent. Click on new agent, and we can see we have been given a pop-up to download the package and configure our agent. So you can choose your agent type as per your requirement. Because I have to configure a Windows machine as a build agent, in first step you can see we have to download the agent package in the build machine, and second step we can see we have to create the agent by giving this command in PowerShell of our build machine, and in last step we have to configure the agent by giving this command. And if our agent service is not running, we can start it manually by using this run command. So I will be using this virtual machine as my build agent. I will click on this. Now I have to configure my build agent. So I will first copy my package URL. I will go to my virtual machine. I will paste the URL and download the agent package. And we can see our agent package has been downloaded in my build machine. Now we have to open our PowerShell in agent machine. Make sure you run the PowerShell in administrator mode. So now I will go back to my Azure DevOps configuration part and I will copy the commands. I will copy the first command and paste it in my build machine. Click enter. Then I will copy my second command. I will paste it to my build machine. Click enter. So now you can see our second command has been run successfully. I will go back. I will copy this next command to configure the agent and paste it here. Click enter and we can see it is asking for server URL. So for server URL we have to provide our DevOps organization URL in which you want to add your agent. I will go back to my DevOps organization. I will copy this organization URL and paste it here. Click enter. Now it is asking for authentication type. I will press enter for PAT. Now I have to provide personal access token or PAT key. I will go back to my organization. To generate a PAT key, we have to click here on user settings, go to personal access tokens, click on new token and generate a token. I will give name as agent PAT. You can choose expiration date and scopes also. I will give full access to this PAT key. Create. I will copy this PAT key, go back to my agent machine. I will paste the PAT key, click enter. So we have to give our agent pool name. As we are using our default agent pool, I will press enter. If you are using any new pool, then you have to give the name of that pool. Now we have to give agent name. I will give any name like agent01. Click enter. And we can see we have successfully added our agent. So now we have to provide the work folder. We will press enter. Now it is asking to run agent as a service. We will provide yes. Press Y. Enter. We don't have to do this configuration. Press enter to skip this. Again press enter to skip this configuration. Now we can see our agent service has been successfully installed and configured. Now it is asking to prevent service from starting immediately after configuration is finished. I will press Y. I will give yes. Press Y. Click enter. And we can see our agent has been configured successfully. To check whether the agent service is running or not in our agent machine, we can go to services. And we can see here our Azure Pipeline agent has been installed. Click on start to start the service. Now I will give this last command. Paste it here. And we can see our agent is working. It is our agent01 is online now and ready to take tasks. So these were the steps to configure our build agent.
So previously we have seen that how we have created and deployed .NET application, React.js and Angular applications. Now in this particular video we will see how we can deploy the same React.js application on an Azure storage account using static website content. So let's get started. First we will see our today's agenda. We will see how to build a React.js application on Azure pipelines. Next, we will see how to release our React.js application on storage account. First, we will see how to build a React.js application on Azure pipelines. So I have already pushed the code on my Azure DevOps account. I will provide the GitHub link of this code in the description below. And I have created a whole series of this Hello World React app, how to deploy and build this React application from scratch. Go and check it out.
Now we can click here on setup on build to create our pipeline, or we can go to pipelines. We can create a new pipeline. First we have to select our code. So we will select Azure Repos. I will select my repo. This is my repo. So we can see that Microsoft Azure DevOps has analyzed our code and it is giving us this many options to build our code with Node.js and React. So I will select this option because our project is Node.js with React. You can see this is the default generated YAML file created by Microsoft Azure, but we can configure this with our own purpose. So now first you can see the trigger is our main branch, then pool, it is selecting Ubuntu data as the default build agent for this job. Then the steps is to first, then we can see the steps. So the first step, as you can see, is to install the Node tool. That means it is installing Node.js software to our build machine. As I have installed Node.js to my local system in previous video, I have told you this. So it is installing Node.js into its build machine. So you can see the input parameters. The version it is installing is 10x and the display name is install Node.js. So we have to do some changes. So our React application is the latest version. So we can change it to 16x. Now we can see the second task it is doing. It is executing some scripts like npm install and npm run build. So these two commands I have told you in my previous video. We have run these commands in our local system to compile our Node.js application. So before this, we will see that what files are being generated before compilation of code and after compilation of code. So I will give the script before npm run build, and script will be echo build viewing files before compilation we have to give this. If we are running multi-line scripts, then I will give second command or script at ls build dot sources directory. So guys, if you are not familiar with this variable, so you can check it out my previous video. I have explained these things in depth. So this command will help us to view our files before compilation, and same we will do after compilation. Copy this command and I will give viewing files after compilation and build.source directory. I will provide a display name. Display name will be viewing before build, and the second one will be after build. Now our code has been completed. Now we will run this pipeline. We can see the jobs. It will take a while. So we can see first it is checking out our code from Azure Repos to its build machine. It is installing Node.js, Node 16. Then we can see the file before build. So these are the files before building or compilation of our code. We can compare these files with our Azure Repos files. We will get the same number of files here also and here also. So there is nothing new here. Then it is executing the commands npm install and npm run build, and it is compiling our code, and we can see after build node modules and build folder is generated. We can compare it again. Before build we don't have these two files, and after build we have build and node modules. So node modules, as I mentioned earlier in my previous video, node modules, it contains all the packages and dependencies to build our code. Then build folder contains the static web page or static files. It is also the artifact folder. So our job has been done here. Now we will move ahead and we will see how we can store our artifacts into a separate folder and publish them into pipeline. We will again go to pipeline. Before that, we should rename this pipeline. Pipeline. We'll again edit our pipeline. So we know that we need the build files because the build files contains our artifacts. We will give a task. So this panel is a task panel. Here Microsoft has predefined many tasks, so you can go and just click on the function and you can use it in your pipeline. So I will search one task called copy files. So I will just click on copy files task, and first I will give the source folder. So this is my source folder, control C, and in that we have to go into build folder. I will copy all the contents. Star means all the contents, and target folder will be artifact staging directory. So the copy file task will do what? I will tell you. Just click on add and you can see the code has been pushed here. So the task is copy file, and it is doing what? It is copying the files from build.source directory, and in that from build folder it is taking all the contents and copying into a separate folder called build.artifact staging directory. Guys, again, if you are not understanding these variables, then check it out my previous video. I have explained everything in detail. So now our build files or artifacts has been copied from source directory to artifact staging directory. Now we will move this or publish this artifact to our pipeline so we can see it. We are copying our artifact from source directory to staging directory. Now moving ahead and publishing this artifact to our pipeline. So we can go. We will again search one task, publish, and we can see we are getting one task, publish build artifacts. We will click on this. So it is already taking my artifact staging directory, and it is creating an artifact named drop, and it is publishing to Azure pipelines. So we will click on just add, and we can see publish artifact task has been successfully inserted to our pipeline. So what does it will do? I will explain you once again. It will take our artifact from this folder and it will publish it to our pipeline in a container. I will show how we can physically access that container and see our artifacts. So now we will run our pipeline and see what happens. It will take a while. It is checking out our code, installing Node.js. Then we can see the files before build. It is just compiling our code with npm install and npm run build command. It will take a while. So we can see it compiled our code, and after build we can see we have built a node modules folder here. We don't need node modules as of now. We only need build. So we are copying build from this folder to a separate folder. We can see copy file task is copying all the build files to a separate folder called artifact staging directory. This is the path of that directory, and it is publishing the artifacts into a container. We can see, and the job is finished. We can go and check it out, our container, and if the artifact has been pushed or not. Click here, click on the latest pipeline. We can see in related one work item is published right now. Click here, click on the artifact name, the container name, and we can see these are the build files that we have published to a container.
Now we will see how to release our React.js application to Azure storage account. So now we need to create a storage account. Deploy our application to storage account. Go to portal.azure.com, search for storage account, click on create. Fill up the basic details like your subscription and resource group name. Provide the storage account name. Make sure it is a unique name. Now leave all the settings as default and create it. Click on review. And you can see all the details of your storage account. Click on create. Now this is our storage account. Go to containers, create a container named $web on create. So containers, it means like a folder in your system. So in this $web container, our artifacts will be pushed. You can see it is empty as of now. Now we will go to our pipeline. After publish artifact task, need to add one task. We will add Azure CLI task. We will select our service connection or subscription of our Microsoft Azure. I will select my service connection. Give script type as batch script. Give the script location script. Provide the script. This is the script. Click on add. I will provide you this script code in the description below. Change service type batch to bash. Now we can see our script is Azure Storage Blob upload batch -s. Our artifact staging directory, our artifacts are present, our pipeline, then -d and the container name $web, -f account name. We have to provide our storage account name. It is stored in the variable, so we need to provide the value of this variable. Storage account key. -f overwrite is to overwrite if there is an existing code or artifact present there. We need to remove this extra quotes. So now we need to provide the storage account name and storage key. Code above. Below the pool section, we'll give variables. After that, we need to provide our variables value, storage, account, name. Make sure your spelling is correct. This is the spelling of my first variable. I will copy this, paste it here, and we'll give the value of this variable. Our storage account name is K567. We will give single quote and give the value. Then we need to give the value of our second variable, that is storage account key, I guess. Let me just see the variable and copy this. So these are the credentials of our storage account so that our Azure DevOps can connect to our storage account. Now we need to provide the value of storage account key. Go to storage account, scroll down instead, go to access key. See, here is keys present here. Click on show, copy the first key, go back, paste the value in single quotes. We can see we have done our job here. Now this Azure CLI task will take all our variables value here from here, load our artifacts from artifact steering directory to our $web container of our storage account. Save and run this pipeline. You can see the artifacts that has been published are the now we need to see that our these artifacts are in our storage account $web container. Go to storage account, click on $web, and we can see our all artifacts have been released here. Now we need to host our website at the storage account. Create a website out of it. We need to scroll down here, go to static website. As of now it is disabled. Need to provide the index document, that is index.html. Copy the primary endpoint, paste it in a new browser. We can see our React.js application has been hosted. So these were the steps. Host our React.js application with the help of Azure storage account.